Hey guys, tonight we're going to do something a little different. I want you to close your eyes and imagine the world as you know it. The continents, the cities, the quiet hum of life, and then I want you to imagine it stripped away. Tonight we're going to pull a cosmic plug and let the oceans drain. I know it's a strange thought, but bear with me. Picture the slow, impossible retreat of the water, a new shoreline forming not in inches or feet, but in miles. See the ships, once graceful dancers on the waves, now resting awkwardly on a newfound seafloor, their hulls caked in salt and ancient mud. The sound you once knew, the constant rhythmic whisper of the tide, is gone, replaced by a profound and unsettling silence. It's an impossible scenario, a thought experiment on a planetary scale. And to be perfectly honest, you probably wouldn't survive to see much of it, but that's not the point. The point is to explore, to wonder, to let our minds wander across the landscape of a world remade. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And if you're feeling up to it, let me know where you're listening from tonight and what time it is for you right now. Let the world know we're all here together in this quiet little corner of the internet. Now, if you're ready, let's begin our journey into the silent, newly born world. The first thing to go would be the illusion of permanence. We look out at the sea, and it seems to have always been there, a vast, unchanging blue. We see it as the horizon, the end of our known world, but in reality, it is a living, breathing entity, a character in a much longer story than our own. We think in terms of centuries of lifespans and generations. The ocean thinks in eons. It has been a canvas for geological change, a cradle for life, and a graveyard for countless moments in time. The very act of it draining would force a new perspective upon us, one that collapses our understanding of scale. It's like pulling a thread on a tapestry you thought was infinite, only to find the entire design unraveling before your eyes. We would realize in an instant that what we perceive as a constant is, in the grander scheme of things, just a phase. This is the heart of what we call geological time, a concept so vast it's difficult for our human brains to truly grasp. We talk about millions of years as if they are a simple number, but what does that even mean? A million years is a whisper in the wind to a mountain range being carved by ice. It's a fleeting moment for a continent drifting across the globe. Our entire history as a species, from the first tools to the digital age, is but a single, barely perceptible beat in the rhythm of the planet. As the waters recede, they would reveal the continental shelves, the submerged edges of our continents. Imagine a new land, a vast, muddy, and chaotic expanse emerging from beneath the waves. This isn't the familiar sandy beach we know. This is the true edge, the beginning of the great drop-off into the abyssal plain. And what would we see on this new strange coast? We would see a graveyard of biological material, a layer of sediment and decay that has accumulated over millennia. We would see the ghostly outlines of ancient riverbeds and canyons that continued their flow far out into the now empty basin. And as the sun began to bake this new land, a profound transformation would begin. The waterlogged earth, once a quiet sanctuary for countless creatures, would crack and dry. We might find strange, perfectly preserved shells, the remnants of organisms that lived and died millions of years ago before the great beasts of the dinosaur age even walked the earth. This slow, gradual accumulation of sediment and organic matter under immense pressure over inconceivable lengths of time is the very foundation of how we come to understand the process of fossilization. A bone or a shell buried deep and shielded from decay has its organic material slowly replaced by minerals, turning it into a stony copy of what it once was. It is a slow and delicate dance of chemistry and time, a dance so patient that it can turn a fleeting moment of life into an enduring whisper from the past. The disappearance of the oceans would in a way make us archaeologists of a world we thought we knew. The most astonishing and perhaps humbling thing about this entire process is not just what we would find, but what it would force us to confront about our own place in the universe. We are so used to seeing ourselves as the masters of the world, the climax of a grand evolutionary story. But the vast empty basin of the Pacific would put our arrogance into perspective. It is a canvas of forces so much larger than ourselves. It holds secrets that predate us, and in its absence, it would lay bare the raw, unfiltered history of the planet. We would be left with a silent, vast, and terrifyingly beautiful landscape that has no need for us. The sheer scale of it all would be a powerful, humbling lesson. We might finally truly understand our own fleeting presence. The ocean, in a way, has always been the keeper of secrets, a veil that shielded the true face of the planet. And in its absence, we would have to come to terms with the raw, chaotic, and beautiful truth of what lies beneath. What a strange and heavy burden that would be. And yet, despite all the science, despite all the geology and the physics, there remains a poetic mystery about it all. The ocean is not just a body of water, it is a repository of stories. It is a home to creatures we have never seen and perhaps will never see. It is a memory bank of storms and calms of ships, lost and found, of whispers carried on currents. The simple, elegant truth is that we do not fully understand the depths. We have better maps of Mars than we do of our own seafloor. We have explored less than 5% of the oceans. The vast majority of life, of geological wonders, and of the fundamental mechanisms of our planet remain shrouded in a profound and humbling darkness. The draining of the oceans, while a physical impossibility, is a thought experiment that allows us to peek behind that curtain. It allows us to contemplate what we might be missing. What grand designs and strange life forms exist just beyond our reach in a world that is so close and yet so alien? This brings us to a peculiar and often overlooked scientific fact, the phenomenon of supercooling. Imagine the water in the ocean, but on a much smaller scale. It's possible to cool pure water below its freezing point to a temperature of 32 degrees Fahrenheit or even lower without it turning into ice. It's a delicate state of balance, an eerie calm, where the molecules are so still and so precisely arranged that they don't have the energy to form a crystal lattice. But the moment you introduce a disturbance, a single tiny ice crystal or a small vibration, the water instantly and violently freezes. The ocean is, in a way, in a constant state of dynamic supercooling. The forces that govern it are so complex and so interconnected that they maintain a kind of precarious balance. The currents, the salinity, the temperature gradients, they all work together to keep the system in a state of flux. To drain it, to remove that delicate balance, would be to introduce a disturbance of unimaginable magnitude. It would be to pull on that one loose thread that holds the entire cosmic fabric together. Watching as it all unravels, not in a gentle, slow manner, but in a chaotic and breathtaking display of physics and geology run amok. We would be left with an empty basin and a profound question. What was the nature of that delicate balance we just broke? And what will the new silent and desolate landscape become? The answer, of course, is that we have no idea. We can speculate, we can theorize, but the truth is, we don't really know for sure what a planet without its ocean looks like, feels like, or even how it truly works. The retreat of the waters is not a gentle slide, but a revelation, a peeling back of a planetary curtain. As the first section of the continental shelf bakes under the unshielded sun, a new kind of geography is born. The coastline, once a jagged dynamic border, now finds itself miles, even hundreds of miles inland. Where waves once crashed and gulls once cried, there is now an expanse of mud and strange alien rock. The world's maps are instantly obsolete. The familiar shape of North America, Europe, or Asia is now distorted, surrounded by a new muddy plain that extends to a terrifying sudden drop-off. The new geography of desolation is not a barren wasteland, not yet. It is a world of bewildering detail, a library of the Earth's past laid bare for the first time. Imagine for a moment the Mariana Trench, It's the deepest point on our planet, a chasm so profound that if you were to place Mount Everest inside of it, its peak would still be over a mile underwater. Now imagine that chasm as a scar on a dry landscape. It would be a monument to geological violence, a trench so long and so deep, it would make the Grand Canyon look like a mere scratch. This is the scale we are dealing with. We would see the Mid-Atlantic Ridge not as a theoretical line on a map, but as a colossal mountain range, a spine running down the center of the Atlantic Basin, taller and longer than the Andes, and alongside it, a network of canyons, volcanoes, and seamounts, all of them completely new to us, their names and their stories, yet to be discovered. This new world would force us to confront our own ignorance about the very ground beneath our feet. We thought we knew the Earth, but we only knew its surface. And what about the life? The initial chaotic phase would be a tragedy of unimaginable proportions. The delicate ecosystems of the continental shelves would be the first to go. Crabs, starfish, and countless species of fish, once thriving in the shallows, would be left to gasp and perish. The air once so alien and toxic to them would become their tomb. Their bodies, a mix of shell and soft tissue, would quickly become part of the new exposed sediment. It's a sad, violent end, but it is also a beginning. As the sun beats down, a different kind of life would emerge. Not the living, but the dead. The process of fossilization, which we touched on before, would be in hyperspeed. The sheer volume of dying organisms now exposed to the air and the elements would create new mineral-rich layers of sediment. In 1,000,000 years, or 100 million, this new strange layer of rock would be a testament to this very moment, a record of a tragedy etched into the planet's crust. It's a somber thought, but it reminds us that death and change are the engines of the universe, the constant forces that shape and reshape the world around us. This great unveiling would also shed light on one of the most remarkable and counterintuitive facts of our planet's history, the existence of underwater waterfalls. You might think of a waterfall as something on a river with water cascading over a cliff. But in our oceans, there are places where dense cold water from the poles cascades down over the ocean floor, creating a river of water flowing underwater. The largest of these is in the Denmark Strait between Greenland and Iceland, where cold water from the Nordic seas plunges down a drop of over 2 miles. If you could stand on that seafloor now in our drained world, you would see the scar of that ancient flow, a canyon carved by a river that was a river of water in a world of water. It's a testament to the strange and wonderful physics of our planet, to the hidden forces that shape its form. The ocean wasn't just a static body of water. It was a dynamic, moving, and constantly changing system, a ballet of currents and pressures that we are only now beginning to fully appreciate. The sheer volume of what we're talking about here is staggering. The oceans hold over 320 million cubic miles of water. To drain it all is to remove a volume of liquid so vast it defies human comprehension. And what would that leave behind? Not just a muddy plain, but a deep, immense basin. The land we call continents, in comparison, are just the high points of a much larger, more complex geological structure. We are, in effect, living on the peaks of a drowned mountain range. And now, for the first time, we get to see the rest of the mountain. This new dry ocean floor would be a world of its own, with its own geology, its own history, and its own secrets. It would be a world of colossal pressure ridges where tectonic plates once pushed against each other, and of vast, flat, abyssal plains where a quiet rain of sediment has been falling for billions of years. The most humbling part of this new reality would be the sudden and profound understanding of our own smallness. We live on the surface of a sphere, but our perception is limited to a narrow band of land and sky. The ocean's absence would make us realize that we have been living in a kind of magnificent ignorance. The vast empty space where the Pacific once was would serve as a constant reminder of all that we do not know. It would be a physical manifestation of a great mystery, a question mark etched into the very surface of the Earth. This raises a fundamental and fascinating question. Does the truth of a thing only exist when it is revealed? Or was the ocean floor just as real and just as magnificent when it was hidden beneath the waves? The truth is, we don't really know for sure if a thing's essence is tied to its perception. It's a philosophical puzzle as deep and as vast as the ocean that once was. In a way, the draining of the oceans is like a grand thought experiment in entropy. Entropy is the measure of disorder or randomness in a system. When the ocean was full, it was a system of immense complexity, with currents and ecosystems and chemical gradients all working together in a kind of ordered chaos. The draining of the oceans would be an act of profound disruption, a sudden increase in the planet's entropy. The ordered system of the deep ocean would be replaced by a disordered, chaotic, and ultimately lifeless basin. The energy that once flowed through the ocean's currents would be dissipated into the atmosphere. The cycle of life and death, once so perfectly balanced in the deep, would be violently interrupted. It is a reminder that the universe, in its most fundamental sense, is a journey from order to disorder. And in this moment, we would be a witness to that journey on a planetary scale. It's a chilling, but also a beautiful thought. The slow decay of everything is a law of nature, and now we would have a front row seat to its most dramatic performance. The silence, once a strange and unsettling thing, begins to feel like a permanent state of the world. As our gaze sweeps across the newly exposed basin, our attention would inevitably be drawn to the ghostly forms of what were once vibrant, pulsating cities of life. The great coral reefs, those magnificent and colorful gardens of the sea, would now lie exposed, their intricate architectures baked white under the relentless sun. The reef is not a single entity, but a collective, a vast city built by countless individual coral polyps, each one a tiny animal secreting a limestone skeleton. It is a slow, methodical construction that takes thousands of years, a testament to the power of a million small actions, adding up to something spectacular. And now, they are all gone. The tragedy of the reefs is not just the loss of the corals themselves, but the unraveling of an entire network of life. The coral reef is a microcosm of the planet's interconnectedness, a brilliant illustration of symbiotic relationships. It is a world of partnerships. The coral polyps, for example, have a vital relationship with microscopic algae called zooxanthellae that live within their tissues. The algae, using sunlight, produce food for the coral, giving them their vibrant colors. In return, the coral provides a safe, protected home for the algae. It's a perfect, beautiful exchange. But with the water gone, the light from the sun, once a gentle source of life, is now a brutal killing force. The algae would die almost instantly, causing the coral to bleach, losing its color and its primary food source. And with the coral goes the thousands of species of fish, crustaceans, and other creatures that depend on the reef for shelter and sustenance. The clownfish, once dancing with the anemone, now lies still on a dry seafloor. The moray eel, once coiled in a dark crevice, now lies exposed. The entire fragile dance of life has come to a halt. As we walk across this new silent landscape, we might find ourselves pondering the nature of these great biological cities. A reef, in a way, is like a living, breathing paradox. It is a testament to the power of cooperation and diversity, a system so robust it can withstand the strongest currents and the most violent storms. And yet, it is also so incredibly fragile, so utterly dependent on a delicate balance of temperature, salinity, and light. The draining of the oceans is the ultimate test of that fragility, a test that the reefs and every other marine ecosystem would fail instantly and catastrophically. The loss of a single thread, in this case, the water itself, has caused the entire fabric to unravel. This reminds us of a fundamental truth about our world, that everything is connected. The air we breathe, the food we eat, the very ground we stand on, it's all part of a vast, intricate system. And to pull on one part of it is to risk the entire structure. One of the more peculiar scientific facts about these reefs is how they contribute to the planet's very structure. Coral reefs are the largest structures on Earth, made by living organisms. The Great Barrier Reef, for instance, is so large it can be seen from space. But what's even more fascinating is the way they've shaped our planet's history. Over millions of years, the accumulation of coral skeletons and other shell-building organisms has formed vast deposits of limestone. This is the same limestone that makes up the white cliffs of Dover, the same limestone we use in cement and construction. The very bones of these ancient forgotten seas are now a part of our modern world. The silent reefs on the new ocean floor are not just a graveyard. They are the future mountains and cliffs of a new geological era, a testament to the enduring power of even the smallest of creatures. The sudden absence of the ocean would also trigger a cascade of changes in the planet's chemistry. The oceans are the great regulators, the planet's lungs and kidneys. They absorb vast amounts of carbon dioxide from the atmosphere, a process that helps to regulate the global climate. They also circulate heat around the globe, preventing the poles from freezing solid and the equator from boiling. Without the ocean, the planet would lose its most powerful stabilizing force. The atmosphere, once buffered by the vast volume of water, would become wild and unpredictable. Temperatures would swing wildly between scorching days and freezing nights. The air itself, once full of moisture and life-giving clouds, would become dry and thin. It is a terrifying thought to imagine our planet as a wild, untamed thing without the gentle, steadying hand of the sea. This grand tragedy of the reefs and the subsequent unraveling of the planet's systems raises a question that scientists still grapple with. How did life begin in the first place? We know that the first life forms were simple single-celled organisms that arose in the oceans billions of years ago. But the exact mechanism by which non-living chemicals arrange themselves into a self-replicating organism is still one of the greatest mysteries in science. We call this process abiogenesis. We have a general idea of the conditions a warm, chemical-rich primordial soup, perhaps around deep-sea vents, where a steady flow of energy was available. But the truth is, we don't really know for sure how those first sparks of life ignited. The silent, empty basin where the oceans once were would be, in a sense, a sterile canvas, a profound and terrifying laboratory where we can contemplate the conditions under which life could or could not arise. It is a reminder that life, for all its resilience and power, is also a miracle, a delicate and improbable dance that began and now has ended in a watery grave. The silent white expanse of the now dry seafloor stretches out to a new, impossibly vast horizon. As we gaze upon this alien landscape, our eyes would be drawn to the colossal, rugged forms that rise from the abyssal plain. These are not the gentle hills of our continents, but a more raw and violent architecture. We are now standing on the mid-Atlantic Ridge, a mountain range unlike any other. It is not the result of erosion or a single cataclysmic event, but of a slow, constant, and unstoppable force. It is the very seam where the Earth's tectonic plates, those immense continent-sized rafts of crust, are being created. The concept of plate tectonics is one of the most elegant and profound ideas in all of geology. It suggests that the Earth's outer shell is not a single solid piece, but a mosaic of massive plates that are in constant, if imperceptible, motion. These plates, which carry our continents and the ocean basins, are powered by the slow churning currents of the Earth's mantle below. At places like the mid-Atlantic Ridge, magma from the mantle rises to the surface, pushing the plates apart and creating new oceanic crust. It's a slow, constant process of birth, a wound that is always healing itself with new rock. The ridge is a testament to this, a colossal scar where new land is constantly being born. And now, for the first time, we get to see it in its entirety, a mountain range that wraps around the entire globe, a monument to the planet's relentless inner life. As we continue our journey across this new rocky world, we would also come to see the deep, terrifying chasms that mark the boundaries of these plates. These are the subduction zones, places where one tectonic plate is forced beneath another, sinking back into the Earth's mantle. It is a process of destruction, a counterbalance to the creation at the ridges. These subduction zones are the engines of the most powerful geological forces we know. They are the birthplaces of great earthquakes and the sources of some of the most spectacular volcanoes. The Ring of Fire. A chain of volcanoes and seismic activity that encircles the Pacific Ocean is a direct result of these subduction zones. In our new waterless world, the Ring of Fire would be visible not just as a pattern of volcanic peaks, but as a vast winding scar on the ocean floor, a testament to the planet's raw, untamed power. The great depth of the ocean once masked the true magnitude of these processes. It was a kind of magnificent insulator, absorbing the energy of earthquakes and the heat of volcanic eruptions. We knew the continents were moving, but we didn't fully grasp the scale of the choreography that was taking place on the ocean floor. Now, with the ocean gone, we are like a backstage crew seeing the gears and the pulleys of the great planetary stage for the first time. We would see colossal faults miles wide, stretching for thousands of miles. We would see ancient volcanoes, their cones and calderas perfectly preserved by the cold, dark depths, and we would be forced to confront the fact that the ground we stand on is not static, but a dynamic and ever-changing surface, a slow geological ballet of creation and destruction. One of the more peculiar and lesser-known facts about our planet's inner workings is the existence of seismic waves. When an earthquake happens, it sends out waves of energy that travel through the Earth. These waves, which are a bit like sound waves, can tell us a lot about the planet's internal structure. There are two main types of seismic waves, P waves and S waves. P waves are compressional waves, a bit like a slinky being pushed and pulled, and they can travel through both solid rock and liquid. S waves, on the other hand, are shear waves, a bit like a rope being shaken side to side, and they can only travel through solid material. By studying how these waves travel through the Earth after an earthquake, scientists were able to deduce that the Earth's outer core is liquid while the inner core is solid. In a world without oceans, the seismic landscape would be completely different. The sudden removal of the immense weight of the water would change the stresses on the planet's crust, and the seismic activity would be chaotic and unpredictable. We would be a witness to a new kind of geological instability, a planet groaning under the sudden absence of a familiar weight. This leads us to a profound philosophical question. The ocean floor, once hidden and mysterious, is now a book laid open. We see the truth of the planet's history, the scars and the triumphs of eons of geological activity. But what about the things that are still hidden? We have peered into the depths of the Earth with seismic waves, but we have never seen the mantle or the core with our own eyes. We have never truly understood the forces that drive the plates or the ultimate destiny of this great geological dance. Is there a point where we will know everything about our planet, or will there always be a core of fundamental mystery? The truth is, we don't really know for sure if our quest for knowledge has a final destination. We can only continue to ask questions to push the boundaries of what we know, and to stand in quiet awe of the vast, beautiful, and terrifying universe that surrounds us. The new dry surface of the Earth is a canvas of desolation, but as we continue our slow journey, we realize it is also a library of untold stories. The quiet basins that once held immense oceans are now a vast archaeological site, a graveyard of human history. The watery depths were not just an empty void. They were a preserver, a silent witness to our ambitions, our tragedies, and our forgotten moments. The draining of the oceans is the great unveiling of this hidden past, a moment when the echoes of sunken worlds are finally allowed to whisper their stories to the silent air. Imagine walking across what was once the floor of the Mediterranean Sea. The basin is now a vast, salt-crusted plain, but here and there you would see the ghostly outlines of ancient shipwrecks. Not just one or two, but thousands upon thousands of them, each one a silent monument to a journey ended. The ships of the ancient Romans, the Phoenicians, the Greeks, Their wooden hulls, once a testament to their skill and ingenuity, would now be resting in a dry, dusty trench. The deep cold and low oxygen environment of the seafloor is a perfect preserver, a kind of natural time capsule. The absence of light and the slow pace of decay meant that these ships, along with their cargo and the personal belongings of their crews, were often left remarkably intact. We might find amphorae still filled with wine coins, bearing the faces of forgotten emperors, and even ancient navigational tools, all waiting for us to discover them. It is a humbling thought to realize that our understanding of history is so limited, that so much of it is still hidden from our eyes, and the ships are just the beginning. The story of human civilization is a story of coastal cities and trade routes. Over the millennia, as sea levels have risen and fallen, entire cities have been submerged, lost to the relentless advance of the waves. The mythical city of Atlantis may just be a legend, but the reality of lost cities is not. The submerged city of Thonis Heracleion, a major port in ancient Egypt, was lost to the sea for over 1,000 years before being rediscovered. The city of Pavlopetri in Greece, believed to be one of the oldest submerged archaeological sites, is a testament to an ancient thriving civilization that was lost to time. Now in our waterless world, these cities would be revealed, their temples, houses, and streets, a ghostly outline on the seafloor. We would see a world that has been hidden for so long, a world that was once alive and vibrant, but has now been returned to the silence. This great archaeological unveiling forces us to consider the concept of archaeological time capsules. These are not just shipwrecks or cities. They are moments in time frozen and preserved. The ocean's silence and darkness were the perfect conditions for this. On land, the constant forces of erosion, weather, and human activity mean that things decay and are forgotten relatively quickly. But in the deep sea, time moves at a different pace. A ship that sank 1,000 years ago might look as though it sank 100. The slow, gentle rain of sediment from above would cover it, protecting it from the destructive forces of the world. The draining of the oceans is like the sudden opening of a vast library of history, a library so immense and so old that it would take us thousands of years to fully comprehend it. This brings us to one of the most fascinating and peculiar truths about the deep sea, the paradoxical relationship between preservation and decay. On the one hand, the deep ocean is an incredibly effective preserver. The lack of oxygen and light slows down the decomposition of organic matter to an almost unimaginable degree. But on the other hand, the ocean floor is home to a host of strange and wonderful creatures that thrive on decay. Deep-sea wood borers, for example, are a type of clam that can bore into and consume the wood of a sunken ship. These creatures, which have never seen the light of day, are the janitors of the deep, slowly but surely recycling the organic material that falls from above. In our new dry world, their work would have come to an abrupt and violent halt, leaving their ghostly trails etched into the wood of the ships they once consumed. It's a testament to the strange and intricate balance of life in the deep, a balance that we are only now beginning to understand. This exploration of a lost world raises a philosophical question that has been asked since the beginning of time. Was this history, these lost cities and forgotten ships, truly lost if no one knew where they were? Does a story exist if it is never told? The truth is, we don't really know for sure if a thing's reality is tied to our awareness of it. The cities and ships were there, but they were silent. The draining of the oceans is the moment they are finally allowed to speak, to share their stories with a world that has been for so long magnificently deaf. And as we listen to their silent whispers, we are reminded that our history is not a neat, clean story, but a wild, chaotic, and beautiful tapestry of triumph and tragedy, with so many threads still hidden from view. Our journey across the newly formed landscape of the ocean floor has revealed a world of immense scale and geological power. But as our eyes adjust to the absence of water, we must now turn our attention from the grand tectonic forces to the smaller, more bizarre inhabitants of the deep. For a moment, let us forget the vastness of the empty basins and focus on the strange and resilient life forms that once called them home. These were not the sunlit creatures of the coral reefs or the shallow waters. They were the masters of darkness, the architects of life in a world of crushing pressure and eternal night. These are the creatures of the abyssal plane, the unseen architectures of life. Imagine walking across the floor of the Pacific and stumbling upon a field of glowing organisms. These are not bioluminescent creatures in the way we might imagine, like fireflies on a summer night. This is a different kind of light, a cold, ethereal glow that emanates from the deep, not as a celebration, but as a form of communication, a warning or a lure. The deep sea is a world without sunlight, and so life had to adapt. Many creatures, from anglerfish with their glowing lures to vast fields of bioluminescent plankton, use this light to survive. This phenomenon of bioluminescence, the production and emission of light by a living organism, is a testament to the sheer adaptability of life. It's a chemical process, a kind of internal fire that allows these creatures to hunt, mate, and defend themselves in a world where vision is a luxury. Now, in our waterless world, their light would be a memory, a phantom glow on the dusty, dry seafloor. But the bioluminescent creatures are just the tip of the iceberg. The deep sea is also home to an entire world of extremophiles organisms that thrive in conditions we would consider to be completely hostile to life. Think of the hydrothermal vents, those volcanic fissures on the ocean floor, where superheated mineral-rich water spews from the Earth's crust. In these vents, there is no sunlight. The water is scalding, filled with toxic chemicals, and the pressure is immense. And yet, life thrives. Tube worms, clams, and shrimp, all completely alien in form and function, have built entire ecosystems around these vents, using chemosynthesis, the process of using chemical energy instead of sunlight to create their food. These are creatures that have never in their entire evolutionary history seen the sun. Their entire world is one of darkness, heat, and pressure. And now, as the vents are exposed to the cold, dry air, their ecosystems would collapse in an instant, leaving behind a field of dead, calcified life. It is a sobering thought to realize that an entire branch of the tree of life, so strange and so beautiful, could be gone in a single quiet moment. The existence of these extremophiles forces us to reconsider our definition of life itself. We as humans are so accustomed to our own narrow set of requirements for survival: oxygen, liquid water, a certain range of temperature and pressure. But the creatures of the deep sea have shown us that life is far more resilient, far more creative than we ever imagined. It raises a fascinating philosophical question. If life can exist in such extreme conditions here on Earth, what does that say about the possibility of life elsewhere in the universe? Could there be life on the moons of Jupiter, in the dark, cold oceans beneath a shell of ice? Could there be organisms on other planets that have developed their own unique forms of energy, their own strange methods of communication? The truth is, we don't really know for sure what the conditions for life are. We only know what they are for us. The silent, dead basin of the ocean floor. Once a home to these creatures, is a profound and terrifying reminder of the vast, humbling, and endless possibilities of life. There's a curious scientific fact that is worth contemplating here: the phenomenon of superheated water. Water normally boils at 212 degrees Fahrenheit at sea level, but under the immense pressure of the deep sea, water can be heated to over 750 degrees Fahrenheit without boiling. It remains in a liquid state, a kind of superheated fluid that is at the heart of the hydrothermal vent ecosystems. This is a testament to the strange and wonderful laws of physics that govern our world. The pressure from the water above is so great that it prevents the water molecules from escaping into a gas, holding them in a tight liquid form. Now, with that pressure gone, the water from these vents would instantly boil, flash steaming into the atmosphere. It would be a final violent gasp of a world that once was a last moment of life and energy before the silence takes over completely. The loss of these ecosystems is not just a biological tragedy. It is also a philosophical one. The creatures of the deep sea represent the most raw, the most fundamental, and perhaps the most ancient forms of life on our planet. They are the living remnants of a time when the Earth was a hot, violent, and chemical-rich world, a time before the sun became the dominant source of energy. In a way, they are the living echoes of the very first sparks of life, and now they too are gone. The silent, empty basin is not just a graveyard of human history, it is a graveyard of life itself. And in this great silence, we are left to contemplate the fragility and the resilience of life, and the strange, beautiful, and utterly alien forms it can take when given the chance. Our journey across the dry abyssal plain has been a constant exercise in grappling with scale, a dance between the colossal and the minuscule. We've considered the grand movements of tectonic plates and the fragile beauty of microscopic life, but now we must turn our attention to one of the most profound and invisible forces that once shaped this world, the weight of a waterless sky. We often forget that the ocean is not just an expanse of liquid. It is a weight, a physical pressure that compresses the very crust of the Earth. The average depth of the ocean is about 1,200 feet, which means that the pressure at the bottom of the abyssal plain is enormous, roughly 16,000 pounds per square inch. This is the equivalent of placing 100 elephants on a single postage stamp. This immense pressure, known as hydrostatic pressure, has a profound effect on the planet's geology. It acts as a kind of counterbalance to the constant upward push of the Earth's mantle. The crust of the Earth is not a static, rigid shell. It is a dynamic, elastic entity. It can bend, flex, and even sink under the weight of a glacier or a mountain range. The vast, heavy expanse of the ocean basins put a constant uniform squeeze on the crust, holding it in a kind of gravitational embrace. Now, with that weight gone, the crust would begin to rebound, to slowly rise like a spring that has been held down for eons and is finally released. This process, known as isostatic rebound, is a well-known phenomenon. We see it happening in places like Scandinavia and Canada, where the land is still slowly rising after the immense weight of the last ice age's glaciers has melted away. But in our drained world, this rebound would be on a scale so vast and so fast that it would be almost unimaginable. The removal of this pressure would have a catastrophic impact on the planet's stability. The crust, now free from its watery weight, would be under immense new stress. The faults and fissures in the Earth, once held in check by the ocean's pressure, would be free to move. This new kind of geological instability would lead to a new era of seismic activity. The mid-Atlantic ridge, which we explored in an earlier section, would be under even more stress, and the subduction zones, where one plate is diving beneath another, would become a hotbed of unpredictable and violent earthquakes. It's a sobering thought to imagine a world not just silent, but shaking, a world where the very ground beneath our feet is groaning under a new, terrifying freedom. One of the more peculiar and fascinating scientific facts about this phenomenon is its relationship to the concept of superfluidity. Superfluidity is a state of matter where a fluid like liquid helium has no viscosity, meaning it can flow without friction. It's a strange and counterintuitive concept, but it helps us to understand the nature of pressure. In a way, the ocean, under its own immense weight, had a kind of quiet, patient flow. The currents, the tides, the slow movement of the deep sea water, it was all a kind of super slow, super heavy dance. Now, with that weight gone, the forces that once governed that dance are unleashed on the solid crust. The Earth itself, in a way, would be experiencing a kind of geological superfluidity, a new unpredictable movement, as it tries to find a new state of equilibrium. It's a beautiful metaphor for a terrifying reality. This new unstable world would force us to confront our own fragility. We build our cities and our lives on the assumption of a stable, solid planet, but the draining of the oceans would reveal that our world has always been a much more dynamic and chaotic place than we ever imagined. It would be a profound and humbling lesson, a reminder that we are just small passengers on a very big, very powerful, and very unpredictable ship. This raises a philosophical and almost spiritual question. Is stability a state of being? Or is it merely a moment of quiet between two violent movements? The truth is, we don't really know for sure if the world we live in is truly stable, or if it is just a brief pause in a much larger, more chaotic cosmic dance. The silent shaking world of a drained ocean is a stark and terrifying reminder of that possibility. The world still groaning under the weight of its newfound freedom is now a stage for a different kind of revelation. We have seen the raw power of geology and the strange beauty of deep-sea life, but now our attention must turn to a much more subtle and yet equally profound feature of the drained basins, the vast gleaming expanses of salt and mineral-rich sediments. The ocean, for all its movement and its life, was also a colossal chemical solution, a slow-moving, immense repository of every element on the planet. And now, as the water has vanished into the atmosphere, it has left its contents behind. We are now standing on the serpent's trail of salt. Imagine the floor of the Mediterranean or the Red Sea, now a vast white and crystalline desert. These seas, once vibrant with life, are now choked with immense salt deposits, the ghost of a watery past. This isn't just common table salt. It is a rich and complex mixture of every mineral and every element that has been washed into the oceans over billions of years. Rivers, for all their beauty and life, are also great conveyors of geological material, constantly eroding rock and carrying the dissolved minerals to the sea. Over time, this slow, steady accumulation has turned the oceans into a kind of planetary soup. And now the water is gone and the soup has crystallized. The process of mineral formation is one of the most fundamental processes in geology. It's the slow, steady coming together of atoms and molecules to form a crystalline structure. In our waterless world, this process has happened on a planetary scale, a kind of catastrophic crystallization that has turned the seafloor into a new kind of geological wonder. The most famous example of this kind of event is the Messinian salinity crisis. It's a scientific fact, not a theory, that about 6 million years ago the Strait of Gibraltar closed and the Mediterranean Sea evaporated, leaving behind a vast salt-crusted basin. The rivers that fed the sea were not enough to replenish it, and the sun did the rest of the work. This ancient event, a testament to the power of geological forces, is a small-scale preview of what we are now witnessing on a global scale. The salt deposits left behind by the Messinian salinity crisis are now a part of the geology of the region, a strange and silent reminder of a time when the Mediterranean was a dry, desolate basin. And now, we would be a witness to a global Messinian crisis, a planetary event that would leave behind a new kind of geological record, a testament to the brief moment when the oceans were no more. The minerals left behind would not just be salt. They would be a rich tapestry of different elements, from magnesium and calcium to gold and silver, all of them dissolved in the ocean's water for eons. The ocean, for all its vastness, was also a kind of gigantic battery, a source of countless elements that are crucial to our modern world. And now they would be laid bare, a new kind of gold rush, on a planetary scale, but the consequences of this would be more profound than just a new source of raw materials. The sudden absence of these minerals from the hydrological cycle would have a catastrophic impact on the planet's chemistry. The very soil on the continents, once replenished by the slow cycle of evaporation and rain, would be starved of these vital elements. The planet would be in a state of chemical shock, a kind of planetary withdrawal from a substance it had relied on for billions of years. This brings us to a deep and a little unsettling question. The minerals and the elements that now lie exposed on the seafloor have a long and complicated history. They were once part of ancient mountains, part of ancient life, and now they are part of this new silent world. Does the material of our planet have a memory? Do the atoms in this salt deposit remember the long journey from an ancient river to the silent crystalline basin? The truth is, we don't really know for sure if matter has a memory. It's a question that borders on the philosophical, but it's one that a landscape like this forces you to ask. It is a reminder that the world is a much more complex and interconnected place than we often give it credit for. The new dry Earth is a world of heat dust and staggering geological features. But as we continue to survey this new reality, we must shift our gaze from the empty basins to the poles, to the last vestiges of our planet's great water reservoirs. We must now turn our attention to the whispers from the cryosphere. The cryosphere is the part of the Earth's surface where water is in a solid state, primarily in the form of polar ice caps, glaciers, and permafrost. The oceans and the cryosphere are not separate entities. They are two sides of the same coin locked in a planetary dance of immense scale and consequence. The draining of the oceans is a catastrophic disruption of this delicate balance, a quiet and profound event that would reshape the planet's climate in ways we can only begin to imagine. The most immediate and dramatic impact would be on the polar ice caps. The Arctic and Antarctic ice sheets, those vast frozen continents of water, are not just sitting there idly. They are in a constant slow-motion battle with the ocean, a battle of creation and destruction. Glaciers, those rivers of ice, are constantly flowing from the land and calving into the sea, adding new ice to the oceans. The sea ice, on the other hand, is constantly melting and freezing, a kind of planetary breathing. The ocean's currents, those great global conveyor belts of heat, are what regulate this process. The Gulf Stream, for example, carries warm water from the equator to the North Atlantic, helping to keep Europe from freezing solid. The draining of the oceans would bring this entire system to a halt. The warm water would no longer flow, and the poles, now exposed to the unfiltered cold of the cosmos, would begin to freeze on a scale never before seen. The glaciers would no longer calve into the sea. They would simply flow onto the new dry land, a silent, slow, and inexorable march of ice. This brings us to a crucial concept in climate science: albedo. Albedo is a measure of how much light and energy an object reflects. The ocean, with its dark, absorbing surface, has a very low albedo. It soaks up a lot of the sun's energy, which is why it plays such a crucial role in regulating the planet's temperature. Ice, on the other hand, has a very high albedo. It reflects a lot of the sun's energy back into space. In our waterless world, the new dry land of the abyssal plain, which is likely to be a dark rocky surface, would also have a low albedo, absorbing a lot of heat. But the polar regions, now without the mitigating influence of the ocean, would become even colder, and the ice sheets would expand. This would create a powerful feedback loop. The more ice that forms, the more light is reflected, which in turn leads to more cooling and more ice formation. It's a chilling thought to imagine a world where the cold and the heat are no longer in a gentle planetary dance, but in a violent, all-or-nothing struggle. There's a peculiar scientific fact about the relationship between ice and water that is worth contemplating. Water in its solid form as ice is less dense than in its liquid form. This is why ice floats. It is one of the most fundamental and counterintuitive properties of water, and it is a property that is essential for life on this planet. If ice were denser than water, it would sink to the bottom of the oceans, and the lakes and seas would freeze solid from the bottom up, making life impossible. The draining of the oceans would, in a way, render this beautiful paradox moot. The ice would no longer be floating on the water. It would be resting on the dry land, a silent monument to a time when its very existence was a life-giving miracle. The glaciers, those magnificent rivers of frozen water, would now be nothing more than static frozen lakes, their slow, patient journey to the sea forever ended. This great climatic shift, this abrupt end to the planetary dance of water and ice, forces us to ask a profound question. The oceans have been the planet's great memory, a repository of our climate's history in the form of ancient ice cores and sediment layers. By draining the oceans and stopping the great currents, we are in effect wiping that memory. We are erasing a billion-year-long story of a planet that breathed and lived and changed. But what does it mean for a planet to have a memory? Does the physical record of its past, etched in ice and rock, constitute a kind of planetary consciousness? The truth is, we don't really know for sure if a planet can remember. It's a philosophical and poetic notion. But in a world without oceans, it's one that takes on a new and terrible weight. The planet now without its great water regulator is beginning to behave in ways we have never seen. The sudden disappearance of the oceans has not only changed the planet's geology and climate, but has also unleashed a new era of atmospheric chaos. The once familiar blue dome of the sky, now devoid of the vast moisture content from the seas, would be transformed into a terrifying and beautiful spectacle. We are now witness to a sky painted in hues of dust. The winds, once a gentle rhythmic flow, are now a wild and unpredictable force, a chaotic dance across a newly exposed and fragile landscape. The most dramatic and immediate effect would be the emergence of colossal dust storms. The new dry abyssal plain is not a solid rock. It is a vast expanse of fine sediment pulverized rock and the salt-caked remnants of a billion years of marine life. Now, with no water to hold it down, this fine dust is a weapon waiting to be wielded by the wind. And the winds, now uninhibited by the friction of the ocean's surface, would be free to reach speeds and scales we have never witnessed. We would see dust storms that dwarf anything on Earth today, storms that could black out the sun for days, turning the planet's sky into a sickly red or a dull, suffocating gray. These storms would carry the fine particles of the ocean floor across the continents, burying cities and reshaping the landscape in a matter of weeks. It's a terrifying thought to imagine a world where the very air we breathe is a silent, suffocating monument to a lost world. This atmospheric chaos is a direct consequence of a fundamental principle of physics, the planet's energy balance. The oceans, with their vast volume and high heat capacity, were the planet's great heat sink. They absorbed a massive amount of solar energy and released it, slowly regulating the planet's temperature. They were also the source of the vast majority of our atmospheric moisture, the very engine of the hydrological cycle. Now, with the ocean gone, the planet's energy balance is completely thrown out of whack. The sun's energy, once absorbed by the dark surface of the water, is now hitting a dry, reflective landscape. The heat that was once slowly released is now radiating back into space or being absorbed and re-radiated by the dusty atmosphere, leading to massive and unpredictable temperature swings. The clouds, those magnificent and life-giving architects of rain, are now a rare and precious sight, their formation limited to the small amount of moisture still left in the atmosphere. This new dusty and chaotic sky raises a peculiar scientific fact about our own atmosphere, the phenomenon of atmospheric circulation. Our planet has a series of large-scale wind patterns, like the trade winds and the jet streams, that are driven by the temperature difference between the equator and the poles. These wind patterns are what drive our weather and our climate. They are, in a way, the planet's great air conditioners, constantly moving heat from the equator to the poles. The draining of the oceans would completely disrupt these patterns. The temperature difference between the equator and the poles would become much more extreme, leading to a new era of violent and unpredictable weather. The jet streams would become wild and chaotic, and the trade winds would turn into a furious dusty gale. It's a sobering thought to realize that the gentle breeze we feel on our faces is part of a much larger and much more fragile planetary machine. This new atmospheric reality, this sky painted in hues of dust, forces us to confront a profound and ancient question. The sky, for all of human history, has been a symbol of hope, of possibility of a world beyond our own. We have looked up at the stars and wondered about our place in the cosmos. But now, with the sky choked with dust and the stars obscured, what does it mean for us to look up? Does the sky still hold its mystery and its promise if it is no longer clear? The truth is, we don't really know for sure if a sky is just a physical phenomenon, or if it is a spiritual canvas for our hopes and dreams. It's a question that a silent, dusty, and starless night forces us to ask. The world of dust and geological chaos is a brutal and unforgiving one. But the most profound and immediate impact of a waterless world would be felt on the continents themselves. The great thirst of the continents is not a gradual process. It is a rapid catastrophic cascade of events that would bring terrestrial life to its knees. The oceans, for all their vastness and their distance, were the very heart of the planetary circulatory system, and without them, the continents are left to wither and die. The first thing to go would be the rivers. The great rivers of the world, from the Amazon to the Nile, are not just a static body of water. They are a dynamic living system, a product of a constant cycle of rain and evaporation. The water from the oceans evaporates, forms clouds, and is carried over the continents, where it falls as rain, filling the rivers and the lakes. This is the hydrological cycle, the planet's great engine of life. Now, with the oceans gone, this cycle would come to an abrupt and terrifying halt. The rain would stop. The rivers, now cut off from their source, would begin to dry up their beds, becoming vast, dusty canyons. The lakes, those quiet, peaceful reservoirs of life, would begin to shrink, their shores receding in a terrifyingly short amount of time. The water table, that great underground river that sustains our forests and our farms, would begin to drop, leaving the roots of trees and plants to stretch in vain for a source of life that is no longer there. The impact on life would be catastrophic. The forests, those magnificent and ancient pillars of life, would be the first to suffer. The great rainforests of the world, once a humid, vibrant tapestry of life, would turn into a parched and desolate wasteland. The animals that depend on the rivers and the lakes for their survival would be left to wander in a world of dust, their bodies withering under the relentless sun. It is a terrifying thought to imagine a world where the quiet hum of a forest and the gentle babble of a stream have been replaced by a profound and suffocating silence. The loss of the oceans is not just the loss of the water itself. It is the loss of the very foundation of life on the continents. One of the more peculiar and lesser-known scientific facts about the hydrological cycle is its relationship with atmospheric rivers. These are not rivers in the traditional sense. They are long, narrow bands of concentrated moisture that move through the atmosphere, a kind of river in the sky. These atmospheric rivers are what bring the vast majority of rain and snow to the continents. They are, in effect, the great delivery system of the hydrological cycle. Now, with the oceans gone, the source of these atmospheric rivers would be gone, the delivery system would be empty, and the continents would be left to die of thirst. It's a powerful and poetic metaphor for the interconnectedness of our world. This great thirst of the continents forces us to ask a profound and ancient question. The ocean, for all its vastness, was also a symbol of life, of a constant renewal, and a constant source of possibility. Without it, the continents are not just dry, they are lifeless. Does the existence of life depend on the existence of the very source of that life? Is it possible for a world to be truly alive without a great living ocean to sustain it? The truth is, we don't really know for sure if life as we know it could exist without the ocean. It's a question that a silent, thirsty world forces us to contemplate. The dry, dusty continents are a stark and terrible reminder that life is a delicate and fragile thing, and that its existence is a constant and often precarious dance with the forces of the universe. Our journey through the desiccated world has been a tour of endings, the end of ecosystems, the end of a planetary climate, the end of the hydrological cycle. But now, as we stand on the floor of the empty ocean basin, we must turn our gaze backward to a time before all this, to a moment of beginning. We must now contemplate the cradle of the first dawn, the silent, chemical-rich waters where life itself first sparked into being. The silent dead basin is not just a graveyard. It is also a powerful, terrifying canvas where we can contemplate the origins of life itself. For billions of years, the ocean was a warm, chemical-rich solution, a kind of primordial soup where the fundamental building blocks of life, amino acids, nucleotides, and lipids were created. The atmosphere was different back then, a volatile mix of methane, ammonia, and water vapor, with very little free oxygen. There were no plants, no animals, and no life as we know it. There was just a constant dance of chemistry a slow, patient process of atoms coming together and breaking apart. This process by which non-living chemicals arrange themselves into a self-replicating organism is one of the greatest mysteries in science, and it is known as abiogenesis. It's not a single event, but a long, slow, and delicate process that took millions of years. And it all happened in the ocean. One of the most famous and compelling pieces of evidence for abiogenesis comes from the Miller-Urey experiment. In the 1950s, scientists Stanley Miller and Harold Urey created a sealed apparatus that mimicked the conditions of the early Earth. They filled it with the gases believed to be in the primordial atmosphere and added a pool of water to represent the ocean. They then subjected the mixture to electrical sparks, simulating lightning. After a week, they found that the water in the apparatus had turned a murky brown, and upon analysis, they discovered that it was rich in amino acids, the very building blocks of proteins and life itself. The experiment, while not a perfect recreation of the early Earth, was a powerful demonstration that the fundamental building blocks of life could be created from non-living matter under the right conditions. The silent, dusty basin is now a laboratory, a place where we can truly appreciate the conditions under which this miracle of life occurred. We can see the chemical-rich sediments, the volcanic fissures, and the deep-sea vents that were once the heart of this process. The absence of water is a kind of erasure, a wiping of the slate that forces us to see the fundamental geology and chemistry that made life possible in the first place. The dry, mineral-rich bed of the ocean is a stark and powerful reminder that the first sparks of life were not a gift from some external force, but a slow, patient, and beautiful accident of chemistry and physics, a testament to the strange and wonderful potential of matter. This contemplation of the origins of life raises a philosophical and often unsettling question. The first life forms were incredibly simple single-celled organisms that lived in a world of constant chemical violence. They were, in a way, the first survivors. But what about us? We, with our complex brains and our intricate societies, are the end product of a 4 billion-year-long journey of evolution. But are we, in our own way, just a more complex and fragile form of those first single-celled organisms? Are we, for all our intelligence and our power, still just a product of a chemical accident? The truth is, we don't really know for sure what the meaning of life is, or if it has a meaning at all. The silent, empty basin, a place where life began and where it has now ended, is a profound and humbling place to contemplate that question. The dry, dusty, and silent world is a constant assault on our senses, a world so alien and so vast that it threatens to overwhelm our very perception. We have journeyed through the geological, the biological, and the historical, but now we must confront the most profound and unsettling change of all, the internal one. We must now contemplate a canvas of unimaginable scale, a new reality that forces us to reckon with our place in the cosmos. The draining of the oceans has not just changed the planet, it has changed us. For all of human history, the ocean has been the end of our world, the great blue and terrifying border. The horizon, that magnificent line where the sky meets the sea, has always been a symbol of both the known and the unknown of the world we inhabit, and the great mystery that lies beyond. But now, with the ocean gone, the horizon is a much different thing. It is a vast, empty chasm, a desolate landscape that stretches to a new, impossibly distant point. Our sense of scale, which has been calibrated by a world of mountains, forests, and oceans, is now completely thrown out of whack. A mountain range in the middle of the empty Pacific Basin would be so immense, so vast, that it would make the Himalayas look like a molehill. Our understanding of what is big and what is small, of what is far and what is near, is now meaningless. This sense of scale, this sudden and terrifying confrontation with a world that is so much bigger than ourselves, is a core part of what we might call the philosophical and spiritual impact of this new reality. We as humans have always had a need to understand our place in the universe. We have looked up at the stars and wondered, and we have looked out at the ocean and dreamed. The ocean, in a way, was a kind of spiritual metaphor for the human condition. It was a source of life and a source of destruction, a thing of both immense beauty and terrifying power. Now with it gone, we are left to stare at a silent, dead basin, and we are forced to ask a new, more profound question. What is the nature of our place in a universe that is so vast, so powerful, and so indifferent? There's a peculiar scientific fact about our planet that helps us to understand this sense of scale, the overview effect. This is a cognitive shift that some astronauts experience when they see the Earth from space for the first time. They see our planet as a small, fragile, and beautiful blue marble, a single interconnected ecosystem without borders or divisions. It's a profound and often life-changing experience, one that forces them to see the bigger picture. In a way, the draining of the oceans is the reverse of this. It is the underground effect, a kind of cognitive shift that forces us to see the smaller, more brutal, and more terrifying details of a planet that is so much bigger and more chaotic than we ever imagined. It is a powerful and humbling lesson, a reminder that we are just small passengers on a very big, very powerful, and very unpredictable ship. The silent, empty basin is not just a physical place. It is a psychological one. It is a place where we are forced to confront our own smallness, our own fragility, and our own mortality. It is a place where our long and complicated history, our great civilizations, and our small ambitions are all dwarfed by a canvas of unimaginable scale. This raises a fundamental and unsettling question. Does a sense of meaning and purpose only exist in a world that is scaled to our own perception? Does the vast and different universe make our own lives meaningless? The truth is, we don't really know for sure what the meaning of it all is. But as we stand in this silent, terrifying new world, we are forced to confront that question and to find our own answers in the quiet, dusty expanse that was once a vibrant and life-giving ocean. We have witnessed the death of a world, a slow and agonizing descent into silence and dust. But what if the story didn't have to end here? What if after all the chaos and all the desolation, the universe offered a second chance? What if we were to consider the hypothetical and impossible task of bringing the oceans back? We must now turn our attention to the final glimmer of the tide, a thought experiment within a thought experiment, a quiet hope in a world of profound despair. The task of returning the oceans to their basins would be an act of unimaginable scale. The water, all 320 million cubic miles of it, is not gone. It has been vaporized, now existing, as a thin, diffuse layer of moisture in the planet's atmosphere. To collect it, to recondense it, and to return it to the basins would require an amount of energy that is simply beyond our comprehension. This brings us to a fundamental concept in physics, thermodynamics. The laws of thermodynamics, particularly the second law, state that the entropy of an isolated system will always increase over time. In simple terms, the universe tends towards disorder. The draining of the oceans was an act of profound entropy, a move from a relatively ordered system to a chaotic one. To reverse this, to bring the oceans back, would be to reverse the arrow of time to create order out of chaos on a planetary scale. It would be an act of such immense energy that it would, in effect, violate the very laws of the universe. The energy required to do this is staggering. The heat of vaporization of water, the energy required to turn a liquid into a gas, is immense. It takes a huge amount of energy to break the bonds that hold water molecules together. The sun, for all its power, has taken eons to evaporate the oceans, and even then it has not done so completely. We, on the other hand, would have to do this in reverse. We would have to create a planetary-scale cooling system, a kind of cosmic condenser, to capture the water vapor and turn it back into a liquid. The energy to power such a system would be astronomical. It would be the equivalent of harnessing the energy of a star of 1,000 stars. It's a humbling thought to realize that the universe has a kind of built-in resistance to order, a natural tendency towards chaos that is so powerful, it is literally a law of nature. The hypothetical return of the oceans also forces us to confront the idea of irreversible change. The world as we have seen has been fundamentally and permanently altered. The delicate ecosystems of the reefs are gone. The unique extremophiles of the deep sea are dead. The geological landscape has been reshaped by the sudden removal of pressure. Even if we were to bring the water back, it would be a new ocean. It would not be the same ocean that once was. The history, the life, the delicate balance that took billions of years to create is now gone. The new ocean would be a sterile, empty, and lifeless basin, a silent and a sad reflection of a world that once was. It's a powerful and a tragic lesson, a reminder that some changes once made can never truly be undone. This contemplation of a second chance of the possibility of a return raises a final, and perhaps the most important question of all. What does it mean for something to be truly gone? Does the memory of a thing, the ghost of a world that once was, have its own reality? Does the silent, dusty basin of the Pacific still hold within its emptiness the echo of the great living ocean that once was? The truth is, we don't really know for sure if a thing's reality is just its physical presence. It's a philosophical and a poetic notion, but it's one that a world of irreversible change forces us to ask. As we stand here, contemplating the impossibility of a return, we are left with the ghost of a memory, a silent and a beautiful reminder that some things, even when they are gone, still have a powerful and an enduring presence. Our journey is almost at an end, a quiet and reflective conclusion to a grand, impossible thought. We began in a world of water, a place of vibrant, pulsating life, and we have ended in a world of dust and silence, a canvas of unimaginable scale. We have seen the raw power of geology, the tragic unraveling of life, and the strange philosophical questions that a silent world forces us to ask. But now, as the dust settles and the wind whispers across the empty basins, we are left with a final and most enduring thought, the memory carried by the wind. The oceans, though gone, are not truly gone. They exist in the memory of the wind, in the geological record of the new landscape, and most importantly, in our own minds. The memory of the oceans is not a scientific fact. It is a poetic one. It is the echo of the tide that once crashed on the shore. It is the ghost of the salt on the wind. It is the silent white bones of the great coral reefs, a testament to a world of beauty and life that once was. The New World, for all its desolation and its silence, is a monument to the world that came before it. The canyons carved by ancient currents, the mountains born of tectonic violence, the mineral-rich sediments that are now a part of the planet's crust. They are all a memory, a silent story of a world that once was. The draining of the oceans has not erased this history. It has merely made it visible. It has, in a way, turned the entire planet into a museum, a place where we can walk and contemplate the ghosts of 1,000 storms and 1 billion years of life. This brings us to a final and perhaps the most important scientific concept of our journey, the phenomenon of cosmic background radiation. This is a faint ethereal glow of microwaves that fills the entire universe. It is, in effect, the echo of the Big Bang, the first moment of creation. It is a memory of a time when the universe was a hot, dense plasma, a time before stars and galaxies even existed. In a way, the empty ocean basin is our own personal cosmic background radiation. It is the echo of a world that once was a faint and beautiful whisper of a time before the silence. The memory of the ocean, like the memory of the universe, is not a thing that can be seen or touched, but a thing that can be felt, a constant quiet presence that reminds us of where we came from. The beauty of this is that the world is a constant story of change and permanence. The mountains will erode, the continents will drift, and the wind will reshape the dusty basins. But the memory of the oceans, the echo of a world that was, will remain. It will be a part of the geology, a part of the chemistry, and a part of the planet itself. This is the enduring truth of our universe, that nothing is truly lost. everything is simply transformed, a constant dance of creation and destruction, of silence and sound. The silent empty basin is not an end. It is a transformation, a new chapter in a story that is as old as time itself. And so we come to the end of our journey, a journey through a world that was and a world that now is. We have wandered through the empty basins, we have climbed the mountains of the deep, and we have contemplated the fragile dance of life and the terrifying power of change. Now, as the dust settles and the wind begins to fall silent, I'd like to gently ask you to bring your awareness back to the place where you are right now. The chair you're sitting in, the bed you're lying on, the quiet hum of your own space. I'd like to gently ask one last time, where is the place you're staying now? The time in that place at this very moment, how is it flowing? Just a quiet, final check-in, a gentle reminder that even in this vast cosmic thought experiment, you are here now in this moment. The world we explored was a world of change and of great upheaval, but your world right now is a place of quiet and of stillness. So let the sounds of the night wherever you are gently brush past you. Let the thoughts of the day slowly fade, like the last light of a distant star. Take a slow, deep breath and let it out. Sleep well, my companion, wherever and whenever you are. Sweet dreams.